So this is the next example. This is a single cylinder 4-stroke petrol engine develops 18.4 kilowatt power at a mean speed of 300 rpm. The work done during the suction and exhaust strokes can be neglected. The work done by the gases during explosion strokes is 3 times the work done on the gases during the compression strokes, and they can be represented by triangles. Determine the mass of the flywheel to prevent a fluctuation of speed greater than 2% from the mean speed. The flywheel diameter may be taken as 1.5 meter. So this is the theta line. This is the theta line. So this is the theta line, and this is the torque line. So this is a zero torque line, zero torque. So the plot of torque is 0 for the suction stroke, 0 for the exhaust stroke, and here a triangle, and here a triangle. So the compression and the expansion can be they are modeled as triangles. Okay, and the area of this, or the area of this triangle, this one, not the shaded one, this whole triangle above the theta line, that is the torque during the expansion stroke or explosion stroke is 3 times the torque due to this. That means if you assume that this height is y and this height is x, since the bases are same, y is equal to 3x. Okay. Now the net work done per second is 18.4 kilowatt. 18.0 kilowatt is the power, so 18.4 into 1000 Newton meter is the work done per second, and number of cycles per second is 300 revolution per minute, or 300 by 60 revolution per second. 2 revolution is 1 cycle, since it's a 4-stroke engine, so it is number of cycles per second is 2.5. Therefore work done per cycle is, work done per second is this, and cycles per second is this. So 18400 by 2.5 is work done per cycle, and that is 7360 Newton meter. And work done per cycle from this diagram is the area of the upper triangle above the theta line minus the area of the lower triangle. So the area of the upper triangle is pi y by 2, and the area of the lower triangle is pi x by 2. So this is the work done per cycle, and that must be equal to 7360, or y minus x is this. Now substituting the value of y in the above expression, that we know y equal to 3x. So if you put it here, then x equal to this and y equal to this. So now we know what is x and what is y. But what is the fluctuation of speed? The fluctuation of speed is, as you know, if you consider that the energy here is E, then this negative area below the mean torque line, below the mean torque, this is the mean torque line, 586 Newton meter. This is negative area. So energy here is E minus area of the shaded area, and energy here is the energy at this point plus this shaded area, and then again the energy decreases, and it is the energy at this point, and that is, you subtract this area from the energy what you get here. So this point and this point. So what is the fluctuation of energy? This shaded portion is actually the fluctuation of energy, because this is the minimum energy and this is the maximum energy. After that again energy decreases because the torque goes below the mean torque line. So here, from here to here, the torque available is this, so which is less than the mean torque up to this point. So energy is decreasing, and here it is minimum, then it is increasing, and here it is maximum, then again it's decreasing, minimum. So here we get E maximum and here we get E minimum. So this shaded portion is actually the fluctuation of energy. So, and the fluctuation of energy will be provided by the shaded area shown in figure. From the theory of similar triangles, base of the shaded area divided by pi, that means this divided by pi is this height divided by y. So height of the shaded triangle divided by y. So here base of shaded triangle minus pi, and what is the height of the shaded area? That is y minus 586, and what is y? 7031. So 7031.85 minus 586 divided by 7031.85. So base of the shaded area is 2.878. Therefore fluctuation of energy is half base into height. Now again use delta E I case omega square. K is 2% on either side of the mean velocity, so 4%, so 0.04. Omega is 2 pi n is 300 rpm, this is omega. So this is the fluctuation of energy, I case omega square, and from here you find out the value of I. And once you know I, you know the diameter, and for a disc, assume the flywheel to be disc, you find out what is the radius of gyration from the diameter, and you find out the mass of the flywheel. So here this is another example where they have shown this diagram. Actually this and this should be same, this point and this point are same. So the torque developed by an IC engine is given by this, where theta is the angle turned by the crank from the inner dead center. The engine speed is this, the mass of the flywheel is this, and radius of gyration is this. So I value is given. Find the power developed by the engine, percentage fluctuation of speed with reference to the mean speed, angular acceleration of the flywheel when the crank has rotated 60 degrees from the inner dead center, that is theta equal to 60 degree, and maximum angular acceleration and retardation of the flywheel. So since the expression of the torque is a function of 2 theta, therefore the angle for the cycle will be pi, because the torque will be repeated in every pi cycle. Because here you are getting 2 theta, and 2 theta is having a period of pi, so this t repeats after pi. So you can take pi as 1 cycle, and the work done per cycle is T d theta, which is this, which you get as 1000 Newton meter. And number of cycles per second, cycle means half revolution, because 2 pi is 1 revolution, so half revolutions. So engine speed is 300 rpm, so 300 by 60 is 5 revolution per second, and 5 revolution means 10 half cycles, half revolution, which is 10 cycles per second. Okay, so number of revolution per second is 5, 300 by 60, and for each revolution there are 2 cycles, because we have considered pi to be 1 cycle. Why? Because in the expression there is 2 theta. And the power developed is then 10,000 pi, which is 31.4 kilowatt. In order to determine the fluctuation of energy, we should first determine the location of B and C. So B and C, because this area, so this is, so if you take the energy here at E, in here as E, then E minus this area, the energy at this point, then that plus this, then this point, then again minus the area under this, you get energy at this point. So here the energy is actually minimum and here the energy is actually maximum, because this is the only portion which increases the energy. So energy has to be minimum at the beginning of this and has to be maximum after the end of this. So T minus T equal to 0 is actually the point of intersection of the mean torque line and actual the T theta curve. So T minus Tm equal to 0. So this is T minus Tm. This has to be equal to 0. This means this is equal to 0. Tan theta is 5 by 3. So you get two values of 2 theta 180 degree apart, and these are the values of theta. So here this is the value, theta is the first one, and the second value of theta 119.5 is for this one. So now you, to get the fluctuation of energy, that is the energy above the mean torque line, is this minus mean torque minus mean torque from 29.5 to 119.5, and you get 583 Newton meter. So this is the fluctuation of energy. Use this formula. I equal to, I is given, omega is given, 583. So you find out Ks. Ks is 0.018. This is the total overall fluctuation of energy. Overall fluctuation of speed, sorry. So at either side it is 0.9% either side, 0.9% either side, and total total is 1.8%. So 0.9% either side and 1.8% overall. Acceleration produced by the excess torque. Excess torque is the excess torque is T minus Tm. So this is the excess torque, 300 sin 2 theta minus 500 cos theta or cos 2 theta, 500 cos 2 theta. So this would be cos 2 theta. So this is the extra torque. So 300 500 sin 2 theta minus 500 cos 2 theta is the extra torque, and at theta equal to 60 degree, this is the extra torque. So extra torque is equal to I alpha. So you get the value of alpha at 60 degree. And here maximum acceleration. So for maximum acceleration, and so what you do is find out the maximum torque. So take dt d theta and equate it to 0. So you get two values of theta, and here these are the maximum and minimum torque. So for maximum acceleration, you take the maximum torque minus mean torque, and for minimum acceleration, the minimum torque minus the mean torque, and you find out the maximum angular acceleration and the minimum angular acceleration. And this is also an interesting problem. A 3-cylinder 2-stroke engine has its cranks 120 degree apart. The speed of the engine is 600 rpm. The turning moment diagram for each cylinder can be represented by a triangle for one expansion stroke with a maximum value of 600 Newton meter at 60 degree from the top dead center. Turning moment is in the other stroke is 0 for all other cylinders. Okay. So determine the power developed by the engine. The coefficient of fluctuation of speed with a flywheel having a mass of 10 kg and radius of gyration 0.5 meter, the coefficient of fluctuation of energy, and the maximum angular acceleration of the flywheel. Okay, so suppose this blue one is coming from the first cylinder. So 0, then after 60 degree it is going to maximum, then at 180 degree it's coming to 0 again, and after 120 degree other cylinder fires, then this is for the other cylinder, the red one, then this green one, this one. Now if you add these three torques, you get the violet one. Okay, so you can find out what this violet one would be from. See here the blue one is 0, but the green one is this much, so it starts from here. So you can find this point, and again at this point the green one is okay, and this green one is, it is starting from 240 and going here, but 360 is here, so 360 is here, so but it should go up to 240 plus 180, which is 420. 240 plus 180, so 360 plus 60, so it will come up to here. So yeah, so it is here, so it will come like this. So at this point, at this 60, this green one is 0 and only this blue one is remaining, so the violet one will having this value. Again you can get this value, this value, this value, this value, and line and join them by a line. So so here at angle 0 degree the first cylinder is 0, at angles the second cylinder is 0, and cylinder 3 is 300. Cylinder 3 is 300. So and at 60 degree the first cylinder is 600, second cylinder is 0, third cylinder is 0. So total torque is 600. So in this way you get the sum of the torques and you can plot this. So you get this point, and again this point, this you can get. So this green one comes to 0, this green one comes to 0 after, so 240 to 60 degree its maximum, so it is up to 320, up to 300, up to 300 it rises, and then for the next 120 it decreases, so it rises by an amount of 600. So 600 it decreases in 120, so in 60 it decreases by sorry, in from here, so in 300 to 60, so it's 120 it decreases by 600, in 120 it decreases by 600, so in 60 it decreases by 300, so from 600 it comes to 300. So this point also you can find out. So you have to first find out this, actually you have to find out the corner points, and since these are linears you can join them by line. So so this is the resulting torque diagram, this violet one is the resulting torque diagram, and once you get this, the rest of the problem is simple. So the torque varies from 300 to 600, again 300, so the mean torque line is at 450. So this is the mean torque line is 450, and actually the fluctuation of energy will be given by this area, because here energy this much it gains, this much it loses, again this much it gains, again this much it loses. So here, from the difference between here to here is the difference between here to here, is the difference between here to here, is the difference between here to here, difference between here to here. So all are same. So only you take this shaded area to get the fluctuation of energy. So let's see what we have done here. So work done per cycle. So 3 cylinders are giving torque, and so 600 into pi by 2. So half 600 into pi divided by 2. Half base is pi, 180 degree, half pi by 2, and base and half pi by 2, and this height is 600. So this is the energy coming from the engine per cycle. So mean torque is this divided by 2 pi. Why 2 pi? Because one revolution is one cycle for a two-stroke engine. This is a two-stroke engine. So 450 Newton meter is the mean torque. And the power developed, the mean torque into twice pi n by 60. So this is 28260 watt. Mass moment of inertia given, and fluctuation of energy is that area. That area means this is 600 minus 450 is the height, and this base. So this base is actually, if this is pi, then this is midway. So this has to be, if this is 0 to 120, if this is 0 to 120, then this has to be 0 to 60. So pi by 3 is this. So half this pi by 3, 600 minus 450 is the height, half height, and base is pi by 3. So this is 120, and this is midway. So this is 60 means pi by 3. So from that you can find out what is your delta E, and you also know the speed. Once you get delta E, I you know, the speed you know, then Ks is the fluctuation of speed is 0.008 overall, so 0.8% overall. And coefficient of fluctuation of energy is delta E by E, where delta E is this and E is energy available per revolution. Here there is no difference between revolution and cycle because it is a two-stroke engine. So this is the coefficient of fluctuation of energy, and the maximum excess torque is 600 minus 450, so 150 Newton meter, and that is responsible for the maximum acceleration. So this is the maximum acceleration. So with this we stop here, and in the next lecture we'll see how to design or how to determine the moment of inertia of flywheel for a punching press.